That technological infrastructure that helped push out and foreground certain kinds of questions was not just an issue for Einstein, it was also so for Henri Poincaré. And we saw how Poincaré was fundamentally interested in sort of a triple intersection of technology, philosophy, mathematical physics, that the very question of simultaneity was for Poincaré all three. It was a very practical matter. He was one of the people in charge of the Bureau of Longitude in Paris, and he was worried about how signals would cross underneath the oceans and come back, and how you could time that to determine simultaneity at different parts of the world. It would allow new forms of navigation, new forms of map making, new forms of military conquest. I mean, mapping the world and covering it with cables, this new communicative, instantaneous world was something that was very much on Poincaré's mind. And so he began to explore this when he talked, as we saw, when he talked about what simultaneity was in his philosophical inquiry of January 1898, he was also talking about something very real. It was not just a brain in a vat thought experiment. It was about real technologies that he had to deal with in a daily way, of what it meant for a telegrapher to exchange signals with another telegrapher to determine longitude. And that work, only a little bit later, in December of 1900, could Poincaré elevate this to an important idea for physics itself and for the electrodynamics of moving bodies. It never was a foundational starting point, this criticism of time, as it was for Einstein, but it was important. And Poincaré moved around speaking to engineers and map makers, speaking to philosophers, speaking to physicists about this triple intersection, this notion that simultaneity really was defined by the exchange of signals correcting for the time of transit as determined by a round trip of the signal. When Einstein, who read Poincaré very carefully, saw these same sets of problems, he had already come to be dismissive of the ether as a fundamental entity, as something that really carried observable consequences. He was interested in electric waves and what that meant. From the age of 16, he was very troubled by the idea that you didn't seem to be able to catch up to an electric wave, to a light wave, and tried to explore what that would mean. Einstein took this idea of signal-based exchanges. He had probably read about it in Poincaré's Science and Hypothesis and the quotes that were there from Poincaré's earlier paper on the measure of time in the German translation. But Einstein put it in a new place in physics. Einstein realized that really up front, at the beginning of the physics that he wanted to do to reform electricity and magnetism, he needed to set this new idea of space and time, this idea of simultaneity as it was determined by the coordination of clocks. He needed to set that front and center, and then from that unfold the new physics. It was for Einstein the final piece in the puzzle, which, when combined with his concern about what Lorentz had done with his idea of a contraction, with what he'd understood of these experiments that seemed to leave no room for a very consequential ether, that if you added this idea of space and time as almost operational notions tied to things you could do. Here's how you coordinate a clock. Here's what I mean by a length of a moving object. I mean I have to measure the front and back of the object simultaneously. What do I mean by simultaneously? I mean I coordinate clocks and they read the same. How do I coordinate the clocks? I exchange a signal from one to the other by bouncing it off B back to A, looking at the round trip time, dividing by 2, and knowing that's the time it takes to get from one to the other. This idea of putting his criticism of space and time up front gave the Poincaré notion of simultaneity as coordinated clocks a new place in the physics. So while Einstein and Poincaré both were engaged in technology, they located the technology differently within their physics. And we've explored that and looked at Poincaré's concern with time coordinating radio signals, time coordinating cables, longitude finding, with Einstein's work in the patent office. All of these are different ways of grasping metaphysics of what it is to do physics, what it is to coordinate time, what simultaneity means, what length really means, and to locate it within a world where these questions were pressing. These questions came out of technological concerns, but they went beyond technological concerns in both cases. Einstein, when his contemporaries like Friedrich Adler, our assassin of relativity, or would-be assassin of relativity, when he compared the different systems, he showed that everyone, Poincaré, Lorentz, ether theorists like Vogt, and others, everyone would distinguish between being at rest in the ether, calling it tau or t, and calling moving in the ether time, the other, either tau or t, or a different name altogether. But Einstein had no distinction between moving in the ether and not moving in the ether, because he didn't think there was a true time based in the ether rest. He called the ether a superfluous notion. This upstart young physicist dismissing in one sweep of the conceptual hand one of the major concepts of the whole of the 19th century. And Einstein found himself almost immediately, after he became a world figure in 1919, the subject of a huge number of attacks, some from his friends like Friedrich Adler, some from his enemies, but everyone was constantly pushing on this idea of criticism that it was just simply impossible to grasp for them that time could really be times, that there was no privileged true time, no ground against which everything else was to be understood as moving. For Einstein, every system had its own time. Every moving system had its own time. And none was more privileged than the other. So when Einstein says the rest frame or the moving frame, he says those are just ways of speaking. You could take the moving frame to be the rest frame and the previously considered rest frame to be moving. This was really quite a revolutionary concept in disturbing what time was. And it only gets worse or better when Einstein, in general relativity, extends these ideas and makes time even more problematic as you move into the non-Euclidean world of space-time, and it enters into cosmological as well as the more local considerations, for instance, of the bending of space-time in the vicinity of the sun.